Every academic teaching process is based on a small struggle between the massive amount of new knowledge and the capabilities of the human mind. The challenge is that to learn effectively, we need to use working memory, which has a very limited capacity. It can only process a small amount of information at a time. Our task as a teacher is to design learning process so that attention and working memory resources are allocated as effectively as possible. According to John Sweller cognitive load theory, students' mental effort can be divided into 3 types. The first is intrinsic load. This arises from the basic difficulty of the material, like a complex formula, a multi-step procedure, an abstract theory, or the number of elements that must be connected at the same time. This load cannot be eliminated, but it can be managed by gradually increasing the difficulty and breaking down complex content into smaller chunks. The second type is extrinsic load. This refers to anything that consumes a student's cognitive resources. For example, chaotic slides, unclear instructions, excessive text, classroom noise, too fast pace, or distracting visuals. This type of load is actually harmful because it takes up a significant amount of working memory. The third type is actual effort that truly benefits learning. It's the mental work put into building patterns, connecting concepts, understanding relationships, and retaining them. Our goal is to reduce chaos, to make room for meaningful effort. Merely organizing information, however, is not enough. The ICAP model, which stands for interactive, constructive, active, and passive, shows that the depth of learning depends on the level of student engagement. The lowest level is the passive level, when students simply listen. The higher level is the active level, when they mark, take notes, or answer questions. The constructive level is even more profound, when students create their own explanation or solutions. We favor the interactive level, when students solve problems together, discuss, and confront their thinking. It's also worth to remember the reversal of expertise effect. Beginning students need clear instructions, examples, and step-by-step guidance. For more advanced students, however, an excess of such guidance can become unnecessary noise. What supports a novice can slow down an expert. The myth of multitasking is also a huge challenge. Student who browse social media during class isn't performing 2 tasks at once. Their attention quickly switches between stimuli, and this reduces working memory capacity. Additionally, a distracting screen can also disturb those sitting next to them or behind them. So, how can we design classes that support deep processing? First, use segmentation. Divide complex concepts into smaller, meaningful parts. Before introducing concept B, ensure students understand concept A. Second, use solve examples. First, show the full solution step by step, then partially complete a task, and only then the full independent work. Third, it's better to present a simple diagram on a slide and discuss it orally than to post a long text and read it aloud. Visuals and speech support each other better than 2 competing sources. Fourth, break up the monologue with short tasks. Good working memory management is one of the most important tasks of a teacher. And although it's difficult, when we limit chaos and distractions, we create a very good space for deeper thinking.